Okay, so let's see this problem here. A thin rod of length 1 meter has been uniformly charged with an electric charge of 10 to the power minus 12 coulomb. Determine the potential of the electric field generated by this charge at a point A on the rod's axis at a distance d equal to 1 meter from its end. The rod is placed in vacuum. Okay, so let us take a rod here. So I'm going to take a rod here. Okay, and let L be the length of the rod. So the length of the rod is L. Okay, and from this end I'm going to take from this end, let me take a point A here, A. Okay, which is so this distance from the end to this A point, okay, this A point, this distance is D. From this end to this A point, I take the distance to be D, end of the rod to A point. Okay, and let me take a small segment of this rod. Okay, and this rod is uniformly charged. Okay, so uniformly charged and it has got a charge. So I'm going to take a small segment of this rod. Say I'm going to take a small segment of this rod. Okay, so small segment I'm going to take, which is, let us say, at a distance x from this point A. Okay, it is at a distance, and I am going to take this distance, this rod, this distance of the rod. You can see here this distance, the thickness of the rod, I can take as dx. Okay, thickness of the rod is dx. Now I want to find the potential. Okay, potential due to this rod at point A. All right, so so let us say that this small segment has got a charge dq. Okay, so this small segment has got a charge. Let dq be the charge on the segment. dq be the charge on the segment. Okay, so dq charge is there, so it will create a potential. So what is the potential created by dq? So dv is equal to 1 by 4 pi epsilon 0 dq divided by x, isn't it? So this segment is at a distance x from this point A, so I'm taking x. So if we take the linear charge density, okay, linear charge density, the linear charge density of this rod. So the linear charge density, if I take the linear charge density to be lambda, okay, so then you know that lambda can be written as q divided by L, right? So what is dq? dq will be equal to lambda into dx, right? So I can write which is equal to q by L into dx. So that will be the charge in terms of the total charge q and length L. So that means I can write dv as 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, dq you can write as q by L, okay, into dx divided by x. So this is the dq value which you will get. Okay, so the dq value is 1 by 4 pi epsilon 0 q by L into dx by x. Okay, now so I once again write here, so the dv value, the potential due to the small element will be how much? The potential due to the small element will be 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, isn't it? Q by L into dx by x. Q by L into dx by x. Now you can see here that I can integrate it from d distance to d plus l distance, isn't it? So d is here and d plus l is here. So this is the length. So total length from point A, if you see, so from point A, if you see, this is this one end is at distance d and this other end is at distance d plus l, right? So I can find the total potential is integral of dv from d to d plus l, d to d plus l, right? So that is equal to integral 1 by 4 pi epsilon 0 into q by l into dx by x from d to d plus l. So this you can you will get q by 4 pi epsilon 0 into l will come out, and dx by x is natural logarithm of x. So integral of natural logarithm of x, when you integrate it between the limits, what is the limits? The limits is d to d plus l, right? So this when you solve it, you will get q by 4 pi epsilon 0 natural logarithm d plus l by d, right? That means the potential is equal to q by 4 pi epsilon 0 natural logarithm of d plus l by d. This is what you are getting the potential due to this entire rod at point A. So which you can write as q by 4 pi epsilon 0 natural logarithm 1 plus l by d. Okay. So now all these values are given to you. L is given as 1 meter. D is also given as 1 meter. Q is given as 10 power minus 12. And what is 1 by 4 pi epsilon 0? 1 by 4 pi epsilon 0 is 9 into 10 to the power 9 Newton meter square by Coulomb square, isn't it? So you will get you got the value of all these values. When you substitute here, you will get the V as how much? The value of V you will get, if you substitute these values, you will get 6.3 into 10 to the power minus 3 volt. Okay. So the potential at this point, you will get V as how much? 6.3 into 10 to the power minus 3 volt. This is the potential due to this rod at the point A. Okay, due to this entire rod at this point A.